Hello students, in the previous class we discussed the concept related to mathematical reasoning. Theory part completed. Just I recall the theory part. The mathematical reasoning, we have discussed the mathematical statement. What is mathematical statement? The statement is a sentence which is either true or false. So, for example, 2 minus 1 is equals to 1. It is a mathematical statement. It is truth statement. If its output is true, it is true. So, 2 into 6, that is equals to 10, say, it is false statement. The output must and should be either true or false. That is said to be mathematical statement. Acceptable, mathematically acceptable statement. So, already we discussed the connectivities. Disjunction, conjunction, implication and by implication. These are the 4 types of connectivities are there to connect the simple statements. 2 compound statements converted into the compound statements. This is defined as, suppose P and Q are any 2 statements. P or Q is defined as it is true for all P and Q. At least one of the P and Q is true. If both are false, then it will be false. That is the definition of P or Q. So, again P and Q. This P and Q is true only when both P and Q are true. And remaining times it is false. Implication is defined as P implies Q is false if P is true and Q is false. The remaining time it is always true. Implication is true if both P and Q values, truth values are same. If both P and Q, the statements have the same truth value, then it becomes truth, otherwise it is false. So, suppose this is P, this is Q. Let us write the truth table for all these once again. P, true possibilities are true, true. Its value is true. True, false, it is another possibility. False, true, false, false. So true, this is also true, this is true, this is false. Again, truth and truth, it is true, the remaining 3 times false. P implies Q, truth implies truth is true, truth implies false, only false, the remaining 2 are also true. Truth by implication of truth is true. Truth implies truth by implication of false is false. This is also false. This is true. So these are the 4 truth tables. These are very, very important for you when you are using the problems. These are the truth values. P R Q, P and Q, P implies Q, P by implies Q. This is conjunction. This is disjunction. This is for implication. This is by implication. So, these are the 4 types of the tables. Okay. Again consider the conditional. P implies Q is conditional statement. P and Q are any 2 statements. For this conditional, we define converse, inverse and contrapositive. Converse, inverse, contrapositive. So the converse of P implies Q is equivalent to Q implies P. The inverse of P implies Q is negation of P implies negation of Q. The contrapositive of P implies Q is negation of Q implies negation of P. These are the 3 statements. These are also very, very important. Converse, inverse and contrapositive. What is this? This is negation. Negation we mean not. This is not. Already we discussed some of the properties related to the connectivities. Let us check what are the properties. P is any statement. P are true. P are true is always truth statement. P and truth. is always equivalent to P, the statement P. And P or false is always equivalent to the statement P. P and false is always equivalent to statement false. This is the very important property for you. P is any statement. P is any statement. If P is any statement, then these four things are valid. And we have discussed P or Q is equivalent to P, Q or P. Again, P and Q is equivalent to Q and P. And also we have P or Q or R is equivalent to P or Q or R. Associative law. Okay. Similarly, P and Q and R is equivalent to P and Q and R. Already we have the distributive law. P, R, Q and R is equivalent to P R Q and P R R. This is said to be distributive law. Similarly, P and Q R R is equivalent to P and Q or P and R. P and R. This is the distributive law. Okay? Associative law, commutative law. All these are valid. Again we have the equality of the two statements. So, mathematically equivalent if their truth values are equal. Truth values of the two statements are equal, then they are said to be logically equivalent. Already we discussed the example. P is equivalent to negation of P. These two are mathematically equivalent. Again, P implies Q is always equivalent to negation of P or Q. P implies Q is always equivalent to negation of P implies Q. What about negation of P implies Q now? This is De Morgan's law. If you apply negation of P implies Q is nothing but negation of P or Q. This is nothing but negation of P means P and negation of Q. By applying the De Morgan's law. Negation of P or Q is equivalent to negation of P and negation of Q. Negation of P is P. P and negation of Q. So, negation of P implies Q is equivalent to P and negation of Q. Already we discussed the negation of P or Q is equivalent to negation of P and negation of Q. Negation of P and negation of Q. Negation of P and Q is equivalent to negation of P or negation of Q. Again, we have P by implication of Q is equivalent to P implies Q and Q implies P. P implies Q and Q implies P. From that, you can easily write this one as negation of P or Q and P, negation of Q or P. Negation of P or Q and negation of Q or P. Because P implies Q is nothing but negation of P or Q. So, these are all properties. We are going to use these properties in our problems. Let us try to do the problems related to the mathematical reasoning. Okay? So, let us move for the problems related to the mathematical reasoning. See this problem. This is the problem for you. The contrapositive of the statement. We are going to find out the contrapositive of the statement. If I reach the station in time, if I reach the station in time, then I will catch the train. This is my statement. If then. So we are going to write the contrapositive for what? If conditions. Implication statements. For implication statements, we write the contrapositive. What is the definition? If P implies Q, P implies Q means what? If P then Q. Its contrapositive is what? Negation of Q implies negation of P. This is the contrapositive. Converse is what? Q implies P. Inverse is what? Negation of P implies negation of Q. Contrapositive is what? Negation of Q implies negation of P. Negation of Q. Suppose I reach the station in time is my first statement. I will catch the train is the second statement. So, which one is correct? Let us see. For this statement, not will be there. This statement also not will be there. If I do not reach the station, so this is wrong. So, first train will be there. If I do not reach the station in time, then I will catch the train. This is wrong. If I will not catch the train, if I will not catch the train, then I do not reach the station. See this one? If I will not catch the train, I will not catch, not will be there. So, if I will not catch the train, then I do not reach the station in time. So, not are applied and Q, P implies Q. Q will be here and we have to take the negation to that one. Negation of Q implies negation of P. Similarly, this is also wrong. If I do not reach the station in time, then I will not catch the train. If I do not reach the station, then I will not catch the train. If I will not catch the train, then I reach the station. This is also wrong. Okay. So, if I will not catch the train, then I do not reach the station is the correct statement. Okay. If I do not reach the station in time, then I will not catch the train. So, I reach the station in time, I will catch the train. I will catch the train. Here we have to follow this one. If I will not catch the train, then I do not reach the station in time. Understand? We will move for the next question. Which of the following is tautology? This is the question. Which of the following is tautology? The first one is negation of P and PRQ implies Q. Tautology means what? The output must and should be true. Then only we say that it is tautology. Okay. For the first option, negation of P and PRQ implies Q is there. What it means? Negation of P and P. This means negation of P and P or negation of P and Q implies Q. This is the distributive law. Negation of P and P is what? Always false. False or negation of P and Q implies Q. False or anything is nothing but anything. So it is nothing but negation of P and Q implies Q. Negation of P and Q implies Q. P implies Q means what? Negation of PRQ. That means negation of P and Q or Q. It means what? Negation of P. P or negation of Q or Q. P or negation of Q or Q. This is nothing but P or negation of Q or Q. Negation of Q or Q. Negation of Q or Q means what? Truth, which is equivalent to P or true. P or true means what? This is true. So the first option is always true. In this manner we are applying the conditions or properties. Or you may take the truth table for this entire statement. you get all truths in the output. Then only you can say that. For that you have to check the 4 conditions. You have to write the properties. You can also catch the answer. That is, negation of P and PRQ implies Q is always tautology. So your output is always true, then we say that it is tautology. See this one. The preposition P implies negation of P and negation of Q is equivalent to what? First option, Q, negation of PRQ, P and negation of Q, negation of PR, negation of Q. This is equivalent to what? So if you are write the truth tables, you have to prepare the truth table for this one and also have to prepare the truth table for all the options. Then only if the outputs are same, which option is same for that given proportion, then that will be the answer. That takes time. If you are going to use the properties for this one, you can directly obtain the answer. See here, what is this? P implies negation of P and negation of Q. P implies negation of P and negation of Q. P implies Q means what? Negation of PRQ. So first of all, I explain this one. P implies, this is nothing but negation of PRQ. P implies just like Q. P implies Q means what? Negation of PRQ. Negation of PRQ means what here? Negation of PRQ. So, negation of PR, negation of PRQ, you may write here also. Negation of PR, negation of P. Statement or statement is nothing but same statement. Negation of PRQ. So, negation of PRQ is the correct answer. This is option C. Understand? So, just by using the properties, you can easily obtain the solution. Understand? If you are going to write the truth tables, sometimes it takes the time. If it is not in a position to write the properties, you may go for the write the truth tables and check whether which of them are equivalent to each other. Next one. See here, this is the question. Given the following 2 statements are like this. This is first statement, this is the second statement. Q or P implies P by implication of negation of Q is tautology. Negation of Q and negation of P by implication of Q is falsy. Then both S1 and S2 are correct. Only S1 is correct. Both S1 and S2 are correct. Only S2 are correct. Like that. So, which of them is correct? So, you may take the truth table or you may take the properties. Suppose P, Q are like that. What are the possibilities for P, Q? True, 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 false, false, true, false, false. So, I am going to check for the first statement. Q or P. Q or P is nothing but PRQ. True, 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 false is there. And then go for negation of Q also. What is the negation of Q? Negation of Q means false, true, false, false. This is negation of Q. P by implication of negation of Q I am going to write. P by implication of negation of Q. Truth by implication of false, false. Truth by implication of true, true. False by implication of false, this is true. False by implication of false, this is also true. Understand? P by implication of Q. Next, what you have to write? Q or P implies P by implication of Q. So, for this, we have to write the if condition. Truth implies false. This is false. No need to write remaining because what they are given to you, this is it tautology they are asking. The first result is false itself. So, this is wrong. So, your first option got wrong answer. And second one is what? Negation of Q and negation of P by implication of Q you have to write. So, this is false statement. Leave it. Again, we have to prepare negation of P also for that. Negation of P is what here? False, false, true, true. false, false, true, true. This is negation of P. Negation of P by implication of Q. I am going to prepare here. Negation of P by implication of Q. This is negation of P by implication of Q. False by implication of true, that is false. False by implication of negation of P by implication of Q. Negation, false by implication of false, this is true. Next, truth by implication of truth, this is true. Truth by implication of truth, this is also true. This is negation of P by implication of Q. Negation of Q and negation of Q is here. False and false. Here you have false. This is false. False and false. Truth and truth. This you are going to negation of Q and negation of P implies Q. So, truth and truth is what? True. We got truth here. So, it is not always false. Therefore, the second statement is also incorrect. Therefore, both S1 and S2 are not correct. S1, both S1 and S2 are, these are not correct. Both S1 and S2 are correct is here. S1 and S2 are correct. One of them should be not there. Both S1 and S2 should not correct. In this manner, we can check the results of the two statements. So, first one is given, that is tautology. It is also failed. For that, first one is false is obtained. And the second thing is given that it is false. And we have the truth for the second statement. That is why both statements are false. Understand? So, both S1 and S2 are not correct. Because these two options are given in the same. That's why I am corrected here, not correct. Both S1 and S2 are correct here. This is not correct. Understand? And let us move for the next question. See this one. What is the contrapositive of the statement? If a function f is differentiable, if a function f is differentiable at a, then it is also continuous at a. This is the statement. What are the options? If a function f is not continuous at a, then it is differentiable at a. Not should be there. So for the contrapositive, P implies Q. What is contrapositive? Negation of Q implies negation of P. So not will be there. Here, then it is also continuous at A is there, not is not there. Therefore, wrong statement. If a function f is not continuous, then it is differentiable. Then it is differentiable. So, it is also wrong. If a function f is continuous, then it is differentiable. There is no not here. That is wrong statement. So, if a function f is continuous at a, then it is not differentiable. Here not missing, it is also wrong. Automatically this may be correct. If a function f is not continuous, continuity is there, the continuous should be appear here. Right? If a function f is not continuous at a, then it is not differentiable at a. So this one is correct option. So the statement will be here and the statement will be here and not will be presented for both. So P implies Q is the statement, negation of Q implies negation of P is its contrapositive. So this is the contrapositive. If a function f is not continuous at a, then it is not differentiable at a. Okay. Let us move for the next question. See here, the negation of the Boolean expression is equivalent to what and what? We are going to find out the negation of this Boolean expression. Which of the following options is correct? So, negation is, this is the not of x by implication of negation of y. Negation of x by implication of negation of y we are going to find out here. So if you want to write, take the statement and write the truth values and take each of the function and write the truth values, then only your job will be over. If you know the properties very well, from itself you can catch which option is correct. So negation of x by implication of negation of y we are considering here. So negation of x by implication of q means what? X implies negation of y and negation of y implies x. In previous class we discussed P implies Q means what? P implies Q, P by implication of Q means P implies Q and Q implies P. That's why I am writing here. Now applying De Morgan's law for this one. This is equivalent to negation of X implies negation of Y or negation of Y implies X. I am applying the De Morgan's law. Negation of x implies negation of y and becomes r. Negation will be here. Negation of y implies x. What is the definition of P implies Q? P implies Q we mean negation of P or Q. So, which is equivalent to negation of x or negation of y. P implies Q means negation of P or Q. Q means negation of y here. Or as it is I am writing. What is P implies Q? Negation of Q. Negation of negation, that is y or Q. Q means x. So if you apply the negation here, x and negation of y, x and y are what? Negation of y and negation of x. Negation of x and negation of y are x and y. See this option? X and y. Okay, x and y is there. R is there. Negation of x or y. Negation of y or x. Negation of y or x is equal to negation of x or y. That is why both are equal. So in this manner, we correct the second option is the correct option. So once if you know the properties thoroughly, you can easily express one Boolean expression to the another Boolean expression. If you are not in a position to apply the properties, you are going to write the truth values for each one of the property, each one of the statement. Then only you get the answer. It takes sometimes time. Next one. The negation of the Boolean expression is equivalent to what? This is the question. All same models, all the problems are same model questions. One question must and should be asked in your JEE mains. So you prepare thoroughly properties, then you can play with all these problems. So what they are asking? Negation of. So this is negation of P or negation of P and Q. This is my question, which is equivalent to what they are asking. So just negation of P or Q type. Entirely I am taking this one as Q. Negation of P or Q. By applying De Morgan's law, what happened? Which is equivalent to negation of P and negation of P or Q. Right? Negation of P. And again I am going to apply the De Morgan's law for this function. Negation of P or Q type. Negation of P means P. R will be there. Negation of Q. Negation of Q. Now I am applying distributive law for this one. Negation of P and P or negation of P and Q. Negation of P and P or negation of P and negation of P and Q. Negation of P and P and negation of P and negation of Q is there. This is negation. Negation of Q is there. Okay. Negation of P and P is nothing but false statement. This is false. or negation of P and negation of Q. Let us see once again. Negation of P and P, okay, R will be outside. Negation of P and negation of Q. Negation of P and negation of Q, which is equivalent to FR, the statement. FR negation of P and negation of Q. I just once again I write this one. What is this? This is some statement. Some just like P say, false or some statement, what happened? Statement will be there. So your result is what now? Negation of P and negation of Q. Your statement is negation of P and negation of Q. So what is the answer? Negation of P and negation of Q. This is the correct option. This is wrong. This is the correct option. Okay, so this one is the correct option. Negation of P and negation of Q is your correct option. So once if you have the properties, you are in a position to write the solutions. Okay, let us move for the next one. This is the question. Consider the statement for an integer n, if n cube minus 1 is even. Consider the statement for an integer n cube minus 1 is even, then n is odd. The contrapositive of the statement is what? This is also for the contrapositive. P implies Q. What is the contrapositive for this one? Negation of Q implies negation of P. You can check that one. N cube minus 1. If n cube minus 1 is not even, if for the integer n cube minus 1 is even, then n is odd. If n is not odd, then n cube minus 1 is not even. You are going to apply not. So for an integer n, if n is even, then n cube minus 1 is odd. So not applied here. See here, n is not odd. That means even. If n is not odd means if n is even, then n cube minus 1 is odd is there. N cube minus 1 is even. Not even means odd. So this is correct option. If Q naught, then P naught is the contrapositive of the statement. So read remaining also. If an integer, for an integer n, if n cube minus 1 is not even, so that is not interchanged here. This is wrong. This is wrong. For an integer n, if n is even, then n cube minus 1 is even. If n is even, n cube minus 1 is even. This is also wrong. For both are even. For an integer n is odd, then n cube minus 1 is even. This is also wrong. So first one is correct option. For an integer n, if n is even, then n cube minus 1 is odd. This is the correct option. Understand? Next one. See here, which of the following is tautology? Tautology will mean the output must and should be true for always. P and P implies Q. P are P and Q. P and P are Q. Q implies P and P implies Q. Which of the following is tautology? This is my question. So P and, if you take the first option, P and P implies Q. You may prepare for the truth table as if at least one of them is false, then your job is over. So true, you take P, Q, this is true, false, false, true. P implies Q is what? True, false, true. Now apply P and P implies Q. P and P implies Q. This is true. This is automatically false. So we obtain false. So this is not correct. It is not tautology. P and P are Q. Again go for P or Q. What we obtain? True, 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 false. P and P are Q. P and P are Q. Is there any possibility for false? So these two statements will obtain false. False and truth, false. False and false, that is also false. So this is also not correct. P and P are Q is also not correct. P are P and Q. Let us try to write the P and Q here. What is P and Q? Truth and truth, truth. False, false, false. Understand? This is P and Q is false like that. P are, if both are false, you get false statement. So this is also wrong statement. P, if it is false, it is also false, the output will be false. So that is also wrong. Therefore, this option is also not correct. Hence, the correct one is Q implies P and P implies Q is the correct option. Q implies P and P implies Q is the correct. Out of 4, 3 are invalid, we mean automatically this will be correct. If you write the truth table, automatically you write the answer. Or you may write this one also. Q implies P. Q implies some P means what? Negation of Q are this. Negation of Q are P and P implies Q. Negation of Q are P and P implies Q. P and P implies Q means what? Negation of P are Q. If you expand this one, that statement always will be true, so automatically this will be true. Or you can prepare the truth table in the same manner, you get all truths, that will be tautology. In this manner, we can crack these simple questions. So, if you know the properties as well as you are in a position to write the truth table for each and everyone, you can easily crack this type of the problems. We will see in the next class some more problems. Okay.